Welcome students. So from today onwards we are going to start another set of problems which are from another book. The name of that book is Basic Circuit Analysis by David Irwin. Okay, so from this book we are going to start another topic here, and that is related to the transients. So what are basically the transients? So basically in transients we have two circuits which are interconnected by using a switch which is turned on or off at any instant t equal to 0. Okay, so we have to analyze the circuit for all instances, I mean for t less than 0. Okay, so what is 0? 0 is basically the instant at which the switch basically turns on and off. Okay, so in this example we can see here that this is the switch which is normally closed here. Okay, so there are basically two types of switches. The first one here, this one, and that is basically the normally closed switch which turns off at, this is the normally closed switch, and it turns off at t equal to 0, and t equal to 0 is the instance at which the switch changes its condition. Okay, similarly we have another type of switch which can be mentioned here. It is denoted by this one, and it is called the normally open switch, and it basically turns on at t equal to 0. Okay, so basically we have two types of switches. This is the normally closed switch while this is the normally open switch, and both of these type of switches will be encountered in this type of examples here. So let us start our example here. So that is basically the assessment problem 7.1, and here we have to find the value of Vc of t for t greater than 0. So what is basically t greater than 0, what is t less than 0, and what is t equal to 0? So t is less than equal to 0 is the instance at which the switch doesn't change its position. Okay, so let us start this one. So when the switch is, this switch is basically the normally closed switch. So when the switch is normally closed, so here we have a capacitor. So in when it is not open, so it is basically in steady state. There are basically two types of states in any circuit. So if the circuit is in steady state, so in that steady state the capacitor will behave like an open circuit, because it will store all the voltage which has been provided to it. Okay, so it will store all the voltage here. Similarly, if it was the inductor here, so in steady state how does it behave? So it will be the short circuit in steady state. Okay, so please remember this point here, that in steady state capacitor will behave like an open circuit which will store all the voltage applied to it, while the inductor will behave as a short circuit which will store all the current which is provided to it. Okay, so these are basically the two states in steady state. So one is a steady state, the other one is a transient state. So transient state is basically opposite as that of these one. What is the transient state? The transient state is that state at which the switch has been closed or opened. Okay, the switch has suddenly changed its position. So in the transient state the capacitor will behave as a short circuit because it will bypass the current here, and the inductor will behave as an open circuit in transient state. Okay, so that is the transient state and that is the steady state. Okay, so these are the two states, and we will basically model our circuit in these two states, and I will again explain all these concepts whenever the circuit will encounter these two states. Okay, so till then we are now concerned with the steady state, which I have shown you guys that in steady state the capacitor will behave as an open circuit and it will store the voltage which is provided to it. So in order to find the steady state here, and when t is less than 0 the switch is closed here. So in order to model the circuit when the switch is closed here, let me draw a circuit here. So the circuit will be like this one, and as the switch is closed here, so it will be like here, and the capacitor here, which is the open circuit, this is our 4 kilo ohm, and similarly this voltage here, this is basically V0 of t, that is plus minus, and this is 2 kilo, and this is the open circuit, this is the 3 kilo ohm resistor, and that is the voltage source of 12 volts. Okay, so now what we have to do, we have to analyze this circuit, and we have to find out the voltage at this point when switch is not opened. Okay, so now in order to do it, we can use many analysis techniques which we have so far used. So let me use a very simplified technique here, in which I have to denote the current here, which is I of t. So in order to find the value of I of t here, what I have to do, I of t is equal to the voltage here divided by the sum of all the resistors, which are 3 plus 4 plus 2, so that is the 9 kilo ohm. So 12 divided by 9, that is 4 by 3 milliamps. Okay, so that is the current here. So in order to find the voltage across 3 kilo ohm, so what it will be, that would be the 3 kilo multiplied by 4 by 3 milliohm, that is the current. So V is equal to IR. So I am writing the value of the resistance here, and similarly the corresponding current which is flowing through this resistor. So now it will be equal to the 4 volts. So now the voltage here will be, that would be 12 minus V3K, that is the same concept which I have told you earlier on. So the VC 0 minus will be equal to the 12 minus 4, and that will be equal to VC 0 minus, and that is 8 volts. Okay, so that is the voltage which is now at the instant when the switch has to be change its position. So similarly here we have two other symbols, 0 minus and 0 plus. So what are those symbols? So the instant when the switch has to change its position, so the very short instant at which it has not change its position is 0 minus, before t is equal to 0, and as it has changed its position, so this very short instant the position it carries is basically 0 plus. Okay, so these are the two symbols which I will be using in these type of circuits and in these type of questions. So that is the initial value here. So now here after this one, the circuit is, now the circuit is broken here and the switch is opened here. So when the switch is opened, what will be the circuit like, as it is now separated out? So the circuit here will be just this, the resistor here, and this one, and this. Okay, as the circuit here is broken now, so therefore we are not going to touch this one, and we are leaving this one, and all the circuit we have to do analysis with is this one. And here the prime source will be this 100 microfarad capacitor, this 4 kilo ohm resistor, and this 2 kilo ohm resistor. Okay, so this is the overall circuit which we have to find out. Okay, so here we have to find out the value of this VC of t. Okay, so now in order to carry out our analysis here, what we have to do, we have to use the method here in which this is the current and this is the other current. So the value of IC is equal to the value of, so according to the KCL, the current which is flowing through this one is equal to the flowing towards this node is equal to the current which is flowing away from this node. So here I of C will be equal to the I of R. This is the I of R and this is I of C. Okay, so that is the condition here. Let me remove this circuit as we are not going to touch this one. Okay, let me remove this one. Okay, so now it will be easy. So IC minus IR is equal to 0. So what is IR? IR is the current which is flowing through this 4K and 2K, as these two are in series with each other, so we can add them together. And what is the value of IC? The value of IC, that is the current which is flowing through the capacitor, and that is always equal to IC dVCT divided by dt. Okay, so that is the current which is flowing through the capacitor. So let me write the values here. So the value of C is 100 microfarad multiplied by dVCT divided by dt, and minus IR, the value of IR is V divided by VC divided by 6, because the addition of these two resistance, and similarly the voltage across both of them is also VC of T, because the combination of these two is in parallel with this VCT. Okay, so now similarly writing this together, VCT divided by 6 kilo, that is equal to 0. Now in order to simplify it, let me multiply both side of it with 6K. So when I will multiply 6K with this one, so it will be 100 into 10 raised power minus 6 multiplied by 6 10 raised power 3. So dVCT divided by dt minus multiplying it with 6K, it will be VC of T, and here it will be equal to 0. Okay, so now let me move down here. Here this will become minus 3 here, because 3 will be cancelled out with this one. So 600 multiplied by 1 over 1000 will be 0.6 dVCT divided by dt minus VCT equal to 0, or dividing both sides by 0.6, what I will get? I will get here dVCT divided by dt minus or plus minus 1 over 0.6 VCT equal to 0. So that is the equation which I needed. So that is a first order homogeneous differential equation. And what will be the solution of this equation? That will be basically, the solution here will be VCT will be equal to K2 exponential of minus T over tau. Okay, so that would be the solution of this equation. And as this is the homogeneous equation and no forcing function is here, because no voltage source was present in the loop which we were analyzing. So in order to find the tau here, we can easily see here that this is the RC circuit. So tau here in this circuit will be RC. So the value of RC is, that is RC, so the value of R is 6K, and the value of C is how much? That is 100 micro. So here ultimately we will get 0.6. Okay, so that would be the value of tau. So let me write it here. What I will get, VC of T is equal to K2 exponential of minus T over 0.6. that is the value here. So now in order to find the value of K2, which is the constant here, and we don't know the value of K2, let me put t equal to 0 here. So putting t equal to 0, what I will get, this will become Vc equal to 0, and similarly k2 exponential of 0. So exponential of 0 is, as exponential of 0 is 1, so here Vc of 0 will be equal to k. Okay, so now writing the value, that is k2. So as we already know the value of Vc0, which we have found out at the instant when the switch was not opened, so that was basically 8 volts. So writing it here, I will get the value of k2 equal to 8 volts, okay, or 8. So that is the constant here, and now putting this value, let me call it B and let me call it C. So putting C in B, okay, it will be Vct equal to 8 exponential of minus t over 0.6. So that is the answer of my question, in which we can easily see that the value of capacitor will be like this one. Okay, so the value of the voltage will decay exponentially, and we can very easily draw it here as well by drawing it. Let me draw it here. So if this is t and this is Vc of t, so we can very easily see that the initial value it will carry will be 8 here, and it will decay at the rate like this one. Okay, and that is the initial value here, and the time constant here is 0.6. So that is basically the question which we had to solve, in which we have find out the transient response of this circuit when t is greater than 0. So that is the mathematical equation for Vc of t when t is greater than 0. Okay, so that's it for this question, and we will solve similar question in our upcoming video lectures. Till then, take care of yourself, and I will see you soon.